Okay, in this video we'll compute the expectation for a geometric random variable, and remember that for a geometric random variable, the probability that x is k is for some number p between 0 and 1, 1 minus p to the k minus 1. Okay, that's the probability that the first k minus 1 trials all end in failure or do not have the event occur. And then we need the probability that the event does occur in the kth trial, and that's p. So remember, a geometric random variable is giving you how many trials it takes until an event occurs, where the event occurs with probability p in each trial. And the trials are independent. Okay, well the expectation, as always, is the sum of the products of the values and their probabilities. Now, I forgot to tell you what the k values are. Since this is the number of trials it takes for an event to occur, it has to be at least 1. And we can't put an upper bound on it. So it's all the positive integers, and we'll be summing from k equals 1 to infinity of the value k times the probability of that value k. Alright, now this is an infinite series that we're not able to, we're not going to be able to evaluate in this class by hand, and the evaluation is actually really neat. This is a derivative of a geometric series. So a geometric series looks like a sum of r to the k. Well, if I took the derivative of that, the k comes down, and the power is decreased by 1. So a neat little tidbit, and you use the formula for this, take the derivative of both sides. It's a nice little trick, but it's not in this class. And if you didn't understand the last 15 seconds, that's just fine. If you did, I think it might be interesting for you. Okay, so we'll go to Wolfram alpha here. And we want to compute the sum of k times 1 minus p to the power of k minus 1 times p, and we're summing that from k equals 1 to infinity. Okay, we'll press enter, and Wolfram alpha will compute the expectation of a geometric random variable for us, and it's just 1 over p. Alright, so we'll go back to our blackboard. And the expectation of a geometric random variable is just 1 over p. Now this is actually rather sensible when you think about what the parameter p is. So x gives the number of trials until the event first occurs. And p gives the probability of the event in one trial. So for example, if p were, say, 0.25, then the expectation of our geometric random variable would be 4. If the probability of the event occurring is 1/4, then we would expect to await somewhere around 4 trials before the event occurs. Okay, so that's the sense in which this expectation really is intuitive.